right, in this section, let's go through a few examples and for using Log's law, and so that we can manipulate and we can come up with a simplified form. All right, let's look at the first one. Example A. We want to write this in terms of x and y and z, but we're going to expand that so that we can include the laws of log. So this is the division. So when you start with this, you make sure that you follow the rules. So first of all, x to the fifth is on top, but there's a division, so you have to do a minus, and then you open up the bracket because y and z, they're in the denominator. That means it's a division. So now you include minus, so this would be log of y base 5. Okay, and again, in this case, because you put the minus outside and these two are multiplication, that means inside has to be inside a bracket. They have to add. That would be log of cube root of z base 5. You close the bracket. Then you have to go ahead and simplify. So right away we're going to include all the laws. So the exponent 5 that can come to the front. So that would be log of x base 5 multiplied by 5 to the front. So that's the 5 to the front right here. And then we're going to go ahead and do the multiplication here. So that would be minus log of y base 5. And then in this case, this, the cube root, is actually, that is z to the power of 1/3. That's what that is. So we can do plus, actually that's a negative because the minus multiplies as well. So it would be negative 1/3 log of z base 5. Okay, and that's all you can do, and then you let it be. So don't forget there's a 5 in front here, and that's basically it. That's the answer. Okay, so for example B, we're going to put it back as it looks like a one single log. We're going to put it back as a single log term. So now we're just going to go backwards. So just be aware. So in this case would be log of, so there is a negative that's outside, and let's say x is on top. So it has to be x on top, okay, divided by, and then log of y and log of z, that means y, z, they are a part of the same term. So that would be y, and then the 3z is actually z cubed, but all of that to the exponent of half. Now you could have written it as log of x divided by square root of y z cubed. Those are exactly the same. It does not matter. Okay, that's log of x on top, and then the base is all 10, and that's okay. So that is your final answer for that. One important part of this is that we need to include, it doesn't say that, but we need to include the accepted values of x, y, z. Okay, so remember the definition. We do have to make sure that x has to be greater than 0, y has to be greater than 0, and z or z needs to be greater than 0. All right, and those are the ones that actually they need to be exactly that, so that if there are any restrictions, we need to eliminate them. This is a perfect segue into our third example. So let's go ahead and try to put that into a single term first, and then let's talk about the restrictions. So here it is. When we are doing the subtraction, that's the division of the argument of the log, and here that is, you can actually go ahead and simplify this rational argument of the log. So remember, that's the difference of the squares. So the bottom piece, so I can rewrite it as log of x plus 5 x minus 5 all over x plus 5 squared. So one of these x plus 5 can divide, so we have log of x minus 5 divided by log of x plus 5. Okay, now we're done. Now you're going to go ahead and write all the restrictions. So remember, so these are restrictions, and it is restrictions on the domain values. Sorry, the x values. Okay, restriction on the domain, that means x values. So here's the first thing. So we know that x squared minus 25 must be greater than 0 or it will not make sense. All right, and we also must have x plus 5 has to be greater than 0. So for each of these inequalities, we need to go ahead and solve. And in this case, it's basically you have to remember your polynomial inequality. So this will be, because it's greater than 0, all x values will be less than -5 and x greater than 5. So that's the only one that will work for this. And then of course, because of you already included that, for the second inequality, sorry, this is number 2, that's number 1, you have x has to be greater than -5. Okay, so and then between the two, which one includes everything else? So it turns out that basically x greater than 5 includes both of these. So the actual restriction for the entire expression is only x greater than 5. Okay, because x greater than -5 is included in x greater than 5, but the x less than -5, that is not included in the second inequality, so we eliminate that. So we're just going to go with the total restrictions for the expression x greater than 5.